Alrighty. So, I noticed yesterday in my video after I watched it, it was a little out of focus, and I think I figured out the reason why. And that's because of the craft mat. So I took it off, and we're gonna do our volume one next. So, I do have another reference sheet, which is pretty cool. So it tells me all of my formulas for my different things we're going to be solving for volume. So this is an amazing reference sheet. I wish I could get these reference sheets to you guys somehow. It's kind of like the best little, like, I call them a cheat sheet, but it's really not, because it's just like you can just have this in your binder. I have copies on copies on copies at my house. So we're just going to be learning about volume today and like composite figures and stuff like that. Look, this even has angles on it too, see? A right angle, 180, linear pairs. This is what we were talking about the other day. It has that on there. Cool, right? We'll probably refer back to that in a little bit. So, let's look at these. Let's look at a few of them. Again, we're using a pen because you can't see when I write in pencil. So, we might need our handy dandy calculator this time. This is my cool graphing calculator. Make sure it's still in focus. Okay, so they want us to write it in volumes of terms of pi and an approximate volume. But the approximate volume we're going to be writing to the nearest tenth. So going back to this, we look and we see this is a cylinder. So let's find our cylinder volume formula. Well, it's right here. The volume of a cylinder is pi r squared times height. So I'm just going to write that down. So I know it's pi r squared times height. And r is radius. So in this one, we're given our height and we're given our radius. So all we have to do is write it in terms of pi. So they don't want us to solve it. They want us to leave it with the pi symbol. So we know this much. But now r squared is 6 squared times 10. Well, on our calculators, we're going to do 6 squared times 10. And we get 360. So it's 360 pi. That's in our volume in terms of pi. So that's more of a accurate volume because we're about to round it, and rounding is it's a lot less accurate. So this is tons more accurate when it's in volume in terms of pi. So now let's just multiply 360 times pi. And we're going to get 1,130. Uh-oh. If we round up, it's going to be this. And make sure we're doing yards cubed, not squared, because we did 3 things. We multiplied by 3 things together, and it's volume, so it's cubed. Okay, so let's go on to this guy here. So this guy, we're given an 8, which is our height, but we're given an 11 all the way across. Well, here's our problem. That's the diameter, and we need the radius. So to find the radius, we're going to take 11 and we are going to cut it in half. We get 5.5. Okay, so now that we have that, now we can do 5.5 squared equals that times 8. And I get 242. Now that is our terms of pi, right? Now multiply 242 times pi, and I get 760.3 when I round it, inches cubed. So this is just the basics of finding volume. They're just giving us cylinders, and cylinders are relatively easy to find once you know that it's pi r squared times height. So I'm not going to finish the other cylinders on here. Let's move back here. Okay. These are more cylinders. Cylinder. So let's move down to a cone. So cone, let's look at our cone. Our cone right here is 1/3 pi r squared times height. So I'm going to take that, what I know, and I'm going to write it down right here. 1/3 pi r squared times height. And I'm going to use it to solve this guy. What I like to do, since I know I have a 1/3, is I'm just going to put everything over 3. And I know I'm going to have a pi. And I love pi. And then my my radius is 2. So it's 2 squared times 5, which is my height. So now I'm just going to plug that bad boy in. And 2 squared times 5. And they don't want us to write it in terms of pi, as you can tell. They just want the approximate. Times pi equals that. And then divide it by 3. And I get 20.9 inches cubed. Okay. So let's try it with this guy right here. This guy, we have a 15-inch diameter, which means we need to cut that in half. 15 divided by 2 is 7.5. So now I have pi times 7.5 squared times 10, all divided by 3. So 7.5 squared times 10 times pi, and then that divided by 3, we get 589.0 is our approximate, and it's inches cubed. Make sure you are putting your units of measure, and they are cubed because it's volume. So that is a cone. I like the cones. So more cones up there, but you know, it's fine. Cones. Hang on, need a drink. Been doing too much talking and singing, so my voice is going. Okay, so how about a sphere? A sphere and a hemisphere. Let's look at these. So the volume of a sphere is 4/3 times pi times r cubed. But the volume of a hemisphere, if you'll notice, is 2/3 pi times r cubed. So the sphere has a 4 on top and the hemisphere has a 2 on top. You're just cutting it in half. But it's the exact same thing with the pi r cubed. Okay? If I can get this page off, that would be nice right now. So let's look at this guy. So we know it's a sphere. So I know I have 4 with the 3 on the bottom with a pi and r cubed, so 23 cubed. And they just want the approximate answer, so we could just plug this into our calculator as 23, and it's cubed, so make sure you're doing it cubed, guys. 23 cubed times 4 times pi equals that, and then we divide it by 3, and we get a big number, which is why 50965.0, and it is feet cubed. Okay, so let's try it with a hemisphere. So hemispheres are 2 instead, with 3 on the bottom, because you're cutting it in half. And pi and 4.8 cubed. Oh my Lord, my power is fluctuating today. That's the second time it's done that. Guys, if it goes out, I'm gonna cry again because I had to stall doing this video because it went out. So 2 times Actually, no, let's do it the other way. 4.8 cubed times pi times 2. Oh, that's not a 2, that's 2. And then divide it by 3. And you get 231.6 millimeters cubed. And so basically just remember when you have a sphere, it's a 4 on top, so it's 4/3 times pi times radius cubed. When it's a hemisphere, it's 2/3 times pi times radius cubed. So let's try this one down here. It's a sphere. Sorry, I'm losing my voice. I've been singing and talking way too much. My throat is sore from that. All right. So let's do this sphere. I know I have a 4 and a 3, and then I have a pi, and then my diameter, my radius is 8, so it's 8 cubed. So should have 8 to the 3rd times 4 times pi is that, and then divide it by 3, and I get 2,144.7 feet cubed. Okay, now let's do another hemisphere, but let's do it with this guy. This guy has a diameter, so we got to cut that in half first. So it's 34 divided by 2, which is 17. So 2, 3 pi 17 cubed. Okay, so now, sorry if I'm moving so fast. I'm trying not to, but sometimes I feel like I do. 17 cubed times 2 times pi divided by 3. 1028.9.8 inches cubed. And I feel like you guys can see this worksheet a lot better. So, I mean, if you want to and you see these problems, just go through and do a few that you feel like doing. Because, I mean, I'm just doing certain ones. So if you feel like, well, maybe I want to do that one and we just did a cone, that's fine. Go ahead and do some. Because I leave them up for a while, right? Enough for you to write down what's there. Oh, that almost went down the wrong throat. The wrong tube. Okay. So that's the basics of volume. Those are given our formulas. So now we have composite figures. So this is putting two different things together. Composite. So looking at this guy right here, we see that it's a square, and squares are easy. Squares and rectangles, when you look at their volume. Their volume is literally length times width times height. That's it. You don't really have to do anything with a square or anything. It's length times width times height. So I know that I need to find the volume of this. So I know that I need to do 9 times 10 times 11. But I also need to find the volume of this guy. And this guy is half a cylinder. Well, we know that the cylinder is pi r squared times height, but in this case, we're cutting it in half because it's only half a cylinder on top. So I know that I have pi times 5 squared times, and our height is actually, where is our height? Our height is right here. So our height is this guy, is 9. 9, because he matches right here. Okay, and we're dividing that by 2. So let's do the math for the first part. So we do 9 times 10 times 11. So this section is 990. So this part is 990. So now let's do this guy. And this is where we get 5 squared times 9, which did I do that? Hang on, let me make sure I do this right. Yeah, okay. 5 squared times 9 times pi. Whoop. Guys, sometimes I struggle with my calculator. Times pi equals that, and then divide it by 2. So I get 2, I get 353.4. So now that I have this is 353.4, now I need to add it to this guy. So 990 plus 353.4. So our volume is 1343.4 inches cubed. So we just added these two together to figure out what the composite volume was. That's basically what we're doing. We're taking what we learned in the last worksheet where we learned the different volumes and just combining it. That's it. So let's find the volume of this composite figure. It looks confusing because where's your radius, right? And you're like, what the heck? Well, secret, I know where it is. But also it's a cylinder, so it's cylinder cut in half. You know, we have pi, and our height is 50. But here's our diameter, because it's the exact same. So our diameter is 25. So to find the radius, cut that in half. 25 divided by 2, we get 12.5 squared. Cool, right? And then the other one, we do 30 times 25 times 50. I like rectangles, they're super quick. So let's do these. And that's where calculators come in handy. So we're gonna do 12.5 squared times 50 times pi, and then divide that by 2 because it's half a cylinder. And we get 1271.8. Now 30 times 25 times 50 equals 37500. That's my kid. I'll call him back in a minute. Okay. So now that we have that, now we're just going to add these two together. So just add that up. 37500 plus 12271.8, and we get 49771.8 centimeters cubed. And that's our volume of that composite figure. Cool, right? I'm trying to see if this is in the shape it needs to be. Okay. Well, now let's figure something else out that's a little more, I guess, intricate, a little more confusing. So, drink. Time out. Oh my goodness, that was so good. Okay. So this says, I like how it got cut off for some reason. So it says tennis balls are usually sold in a cylinder. The diameter, see, we're missing a lot of information because it got cut off. The diameter of the tennis ball is 2.7 inches. The cylinder has a radius of 1.4, and it is 8.5 inches long. What is the volume of air inside the cylinder when it is filled with 3 tennis balls? So this is the diameter of the tennis ball. Sorry, for some reason it got cut off. And I can't spell, so don't worry about my spell. Oh my Lord, guys, don't make fun of me. Oh, I am struggling to spell. Okay, So we need to find our tennis balls first. There's 3 of them. So let's figure this out. Let's figure out our tennis balls first. So they're giving us a diameter, and we know that the sphere, I don't know who that is. So we know that the sphere, its volume was 4/3 pi times radius cubed, right? Well, they're giving us our diameter, so we have to cut 2.7 in half. So it's actually 4 times, but I'm going to show you a little secret in a second, times pi times 1.35 cubed, and we're dividing that by 3, but also we have 3 of these tennis balls. So this is going to be also multiplied by 3 because we need to know how many 3 of these are. But the problem here, it's not really a problem. Let's look at this. If I do that, I'm just going to be doing this, taking that away, and that just makes it like 10 times easier, right? I would think so, because that just goes away, and then we don't have to be redundant and do more work, because 3 divided by 3, 1. So I got rid of my 3's because I know that there are 3 tennis balls, and there's a 3rd on the bottom when you're trying to find volume anyways. So now let's just do let's do 4. Oh, guys, times pi times 1.35 cubed. And then we get 30.9 inches cubed. Okay, so this is the volume of the 3 tennis balls. So each tennis ball is about 10.3 inches cubed. So together they're 30.9. But now it wants us to find the cylinder, because we have to know how much air is in the cylinder when there are 3 balls in there. So our cylinder is pi r squared times height. So we know that our radius of the cylinder is 1.4 squared, and it's times 8.5 because it's inches long, and then times pi. So 1.4 squared times 8.5 times pi equals 52. Oh my gosh, guys, seriously, I'm gonna cry. This is ridiculous. I don't even think you can see my work anymore. The power went out again. What the heck? Hang on. This is like 3rd time today. If I can get this to work, that would be amazing right now. Hey! Can you see? Sweet. So, all right. So now that we have that, this is ridiculous. This is all I have to say about this. This is so dumb. Okay, so now that we know what the volume of the cylinder is, let's subtract it, because they want to know how much air is in there when the balls are in there. So we're going to do 52.3, and we're going to subtract 30.9. So 52.3 minus 30.9, we get 21.4 inches cubed of air. So when there are 3 tennis balls in this cylinder, there is 21.4 inches cubed of air in there. Hey, you guys can see that just fine. This is ridiculous. The power went out the 3rd time today. What am I living in? This is the apocalypse, guys. I'm so over this crap. Oh my Lord, this sucks. Okay. Ugh, so frustrated right now. So this says a bowling ball. So this bowling ball has a diameter of 8.5 inches. Well, we're not doing a diameter. We need a radius, right? So let's figure out the ball first before we move on to the next part. So a bowling ball has a diameter. So let's cut that in half. 8.5 divided by 2. So 4.25 cubed. And then we have 4m pi and 3 because it's a sphere. So let's do this math first. So 4.25 to the third times 4 times pi, and then divided by 3. So we know that the ball itself is 321.6. So that's the volume of the ball. And it's inches cubed. But they want us to see each hole drilled in the ball is 1 inch deep and has a radius of 1/2 inch. What is the volume of a bowling ball with 3 cylindrical holes drilled into it? So these are cylinders. So our cylinders is pi r squared times height. We know our height is 1. We know our radius was 0.5, and it has to be squared. And we know we have to multiply by pi. And in the end, all of this is going to be multiplied by 3 because there are 3 holes. So 0.5 squared times 1 times pi equals 0.785, and then we multiply that by 3, and I get 2.4. So now I have 2.4. I need to subtract that from this guy. So 321.6 minus 2.4. So the volume of the bowling ball with 3 cylindrical holes cut out is 319.2 inches cubed. Wow, right? Guys, this whole power outage thing, not fun. Oh, third time today. Third time. Frustrating. Okay. So let's look at this problem. This is asking us 2 different things. And it's not really, okay. Oh, this is fine. So this says, it's cut out the little top part, but I'll read that. 2 different employees are dishing the ice cream at the Big Scoop ice cream parlor. One of them places a single sphere. So this is a sphere. I'm going to finish this. This is a sphere. So a single sphere of ice cream perfectly in a cone with a diameter of 3 inches. So the diameter is 3 inches. The other likes to pack the entire cone. So this is all filled. And then places a hemisphere with a diameter of 3 inches. So the diameter of a hemisphere, 3 inches, on top. If the height of the cone is 5 inches, how much more ice cream do you get by having the second employee serve you? So first, let's figure out how much the first employee is giving you, and then we'll figure how much the second employee is giving you. So the first employee is only giving you a sphere of ice cream. So the sphere is 4/3 pi r cubed. Well, right here, this is our diameter. So 3 cut in half is 1.5. So 1.5 cubed. So we do 4 times pi times 1.5 cubed, and then divide that by 3. And we get, I did this wrong on mine. We get 14.1 inches cubed. So that's how much ice cream you're getting there. So now let's do this guy. This guy's giving you a hemisphere, but also filling the cone. So let's do our hemisphere first. So our hemisphere is 2, and we know our diameter is our diameter is 3, so our radius is 1.5. Okay, so we're going to do 2 times pi times 1.5 to the third, and I get, and then divide by 3. Almost forgot that part. So I get 7.1 inches cubed for the first part. That's only for the top. So that's only for this. Now we have to do the cone. And the cone is 1/3 1/3. So I know that I don't need the 1 on top. So it's 1/3, and it's radius squared, which our radius is 1.5 squared times pi times height. Then our height was 5. So 1.5 squared times 5 times pi is that divided by 3. I get 11.8. So now let's add these two up, because this is our total amount that we're getting in ice cream. And I get 18.9 inches cubed. But they're asking us, how much more ice cream do you get by having the second employee serve you? Well, this is our second employee. This is our first employee. So subtract. 18.9 minus 14.1. And you're getting 4.8 inches cubed more. I'm going to the second employee. I want more ice cream. I'm sad because I literally just ate all my ice cream last night and I loved it. So this is composite figures. You just need to know what you're adding and what you're subtracting, if you're adding and subtracting. Okay? That's composite figures for now. All right, so this says we're going to use the volume to solve for radius or height. So this is why we need to know our formulas, because we're going to be reverse engineering this. So we're given our volume. So we know the volume is 19.625. We don't know our height, but for a cone, we know that it is with a 3 on the bottom. And we know we have pi, and we know we have 2.5 squared, but we don't know our height. So we're setting this up. So we're just going to solve it like we would solve for any other letter, like if we have a y in there, you know. So to get rid of this 3, we're going to have to multiply by 3 on both sides. So 19.625 times by 3. So that gets rid of this. We get pi times 2.5 squared times height equals 58.875. It's supposed to be 7. It's hard to see with the flashlight on there. Okay. Well, we need to know what 2.5 squared is. So now we have pi times 6.25 times h equals 58.875. I'm going to divide by 6.25. So 58.875 divided by 6.25. I get 9.42 equals pi h, and then divide by pi. I always wait to divide by pi until the end because I don't like dividing by pi right off the bat. And then divide that by pi. And it's about 3. And you have to make sure you're doing an approximation. So height is approximately 3. So we're just reverse engineering this stuff. That's all we're doing. So that's pretty much it. You have to know your formulas before we can reverse engineer stuff. So this next one though, we're looking for the radius. So it's a little bit different. So we have 340.3 equals, we know we have a pi, we have a radius squared, and we have 13. It's divided by 3. Because that's our height. So now let's multiply by 3 on both sides. Gets rid of that. So we have pi r squared times 13 equals 340.3 times 3. This. Okay. Now divide by 13. And I get pi r squared equals 78.5. Problem here is, what did I do with this? Yeah, because it's hard to round when you're doing this stuff. 5307692 Oh no. Then divide by pi, because I have to divide by pi. Ooh, my pi. Because it's going to give me this weird number. So I have r squared equals 24.99712022. And then, since it's squared, take the square root, please, because that's the opposite. And enter. And I get r is approximately, so the radius is approximately 5. See? Just reverse engineering. But when you have a square, make sure you're taking the square root. So let's do it with a sphere, because that's what we're going to have to do, is we're going to have to take the square root. Actually, with a sphere, we have to take the cubed root, which I need to find it on my calculator. It's somewhere on this calculator. I just haven't used it in a long time. Nope. I don't know where my cube root is. Shoot. Hang on. I'm getting there. Hi, guys. Clear. Math. Ah, it's right there. I found it. I have to go into the menu. Okay, so let's reverse engineer this dude here. So we get 5575.3. And we know that our sphere is 4/3 pi r cubed. Well, we don't know our radius, so multiply by 3 on both sides. So 5575.3 times 3, we get 16,725.9 equals 4 pi r cubed. Now divide this by 4 pi. So r cubed equals that divided by 4 pi. And I get 13,6.5. Okay. I don't think I did that right. Hang on. Time out. Sometimes I struggle with my calculator. 16,725.9 divided by, sometimes my calculator is dumb. Yep, it was dumb. I have to make sure I do it that way. So r cubed, because it didn't match all of a sudden, it didn't match the answer sheet. Okay, so now we have to take the cube root. So cube root, I have to go into my math button and then push that, and then push this, and then push this. See? So this is approximately, so the radius is approximately 11 centimeters. Cool. I know, since I messed up on that one, guys. Sorry. Sometimes I struggle with my own calculator. I was like, that didn't look right. So, you know, I struggle. So let's do, see, I don't know why they got cut off up there. It's kind of annoying because those are hemispheres. I want to do this one. Okay, so we're going to do this guy. This is a hemisphere. So it's giving us the volume of a hemisphere. So the volume of a hemisphere is 2.1. And we know the hemisphere is 2, 3 pi r cubed. Let's multiply both sides by 3. So 2.1 times 3 is 6.3 equals 2 pi radius cubed. And we're going to divide both sides by 2 pi. Make sure you don't make the same mistake I did last time. Divide by 2 times pi. And I get radius cubed equals 1.002676141. Now take the cube root. Math. Ah, go back. Sometimes I push the wrong button on this thing. And it is approximately 1. So radius is approximately 1 centimeter. Ta-da! Cool, huh? I just noticed a page in my answer sheet that was rained on and it's all wet. And it looks like it when it was all wet. That's funny. Okay. Cylinder. We're going to reverse engineer the cylinder. The cylinder is relatively easy. I mean, you know, let's reverse engineer this dude. 167.1 equals, we're not given our radius, so we know it's pi times radius squared times 13.3. So divide both sides by 13.3. Wow, guys. Pi. I am so struggling today. 167.1 divided by, not times, divided by 13.3. And then times pi, close my parentheses, and I get radius squared equals 3.999216669, and take the square root of that. No, go back up. And I get, it is approximately 2, right? Yeah, approximately 2. So if you just have to know your formulas, really. That's really all you need to know is the formulas. Because once you know them, then you can reverse engineer things. You can also just solve anything. So that's why my reference sheet is probably my favorite thing that I own. I love my reference sheets. Because if I didn't own these reference sheets, I would probably be like losing my marbles. Because I suck at memorizing things. Well, since my car accident, I really do suck at memorizing things. I'm trying to get better. But, you know, I still struggle. Geometry is not really my strong suit. So getting this was probably one of the most amazing, like, presents I ever got in my life. Was like, I have a reference sheet. This is the most amazing thing ever. So, I don't know how I can get this to you guys. This is amazing. Yeah. So this is just basic volume and stuff like that. I actually highly enjoy this kind of volume. Tomorrow, we're going to be writing linear equations and doing some more stuff with that. Which we learned a little bit about in one of my other things. As it's y equals mx plus b. Stuff like that. But we're going to be doing this tomorrow. Wow. I'm losing my voice. And so I'm kind of glad that I figured this thing out so then I can show you the graphing a lot better. Because this you're going to have to know a lot of graphing for, and it has to be perfect graphing. So, that's tomorrow's lesson. Hopefully got a bunch out of today's. If you need me to go back and do anything extra, let me know. Because after this lesson, we're going to be moving on to some more college stuff. Because this was all of the 8th grade material from Lehigh. And so then I have all my college stuff in my cabinet. I got to find it all. So, that's it for today. Thank you.